2017 paper 2, nice and easy. So let's get it. All right, so this question says, find the first derivative of the function f of x, where f of x is cos inverse of sine inverse of x. So nice and easy. So to find the derivative is going to be f prime of x is equal to, now we need to differentiate cos inverse. When you differentiate cos inverse, what you're going to get is minus 1 divided by the square root of 1 minus, and then it is sine inverse of x all squared. We put it in bracket, sine inverse of x all squared. And then you're going to multiply it by the derivative of sine inverse of x. But the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. Now, if you want, you can just put them together to say, okay, that means the derivative f prime of x is equal to, when you're multiplying two fractions, you multiply across their numerators, so it's minus 1 over, when you're multiplying the denominator, you can just put it as 1 square root. It's going to be the square root of this part, 1 minus sine inverse, 1 minus sine inverse of x all squared, 1 minus sine inverse of x. Sine inverse of x is being squared, of course. All of this, which is multiplied by 1 minus x squared. Nice and easy, soft. And this takes care of the first question. No issues, and that's how you find the first derivative of this. Moving right along. Going right along, so that's part A. Let's look at part B. Part B says, a function w is defined by w of x is equal to ln 2x plus 9 over x minus 1. And it's the modulus of this. But we know the modulus is just telling us that, you know, this can't be negative. Oh no, we can't have the log of negative numbers anyways. So that's no value to us. Now it says, given that dou w by dou x is minus 1 over 9 at the point 4y0, calculate the value of y0. So first, I'm going to rewrite w. I'm going to rewrite w as, this can be written as ln the modulus of 2x plus y, ln the modulus of 2x plus y, minus ln the modulus of x minus 1. Let's write it that way. Now, when we write it this way, we want to find dou w by dou x. Dou w by dou x, it is equal to, we're differentiating the function with respect to x. So it's going to be 1 over 2x plus y multiplied by the derivative of 2x, and the derivative of 2x is 2. So it is 2 over 2x plus y minus, we differentiate ln x minus 1, we get 1 over x minus 1. So that's dou w by dou x. Importantly, they tell us that at this point 4y0, dou w by dou x is minus 1 over 9. So at that point. So at the point 4, y naught, at the point 4, y naught, we're going to have, put in x as 4, so it's going to be 2 over 2 times 4 is 8, plus put y as y naught, and since x is 4, this becomes 1 minus, this becomes 1 over 4 minus 1 is 3, minus 1 over 3, and this is equal to minus 1 over 9. Okay, so what we can do now is bring over the minus 1 over 3 to get 2 over 8 plus y naught is equal to, when you bring over the minus 1 over 3, you add 1 over 3 to both sides. So minus 1 over 9 plus 1 over 3, you get 2 over 9. You get 2 over 9. Now, since the numerators are equal, we can just equate the denominator. So this implies that the 8 plus y naught must equal 9. It works out so smooth. So 8 plus y naught must be equal to 9. And if 8 plus y naught is equal to 9, therefore y naught is equal to 1. Y naught equal 1. So that's the answer. Y naught is equal to 1. Nice and easy. So that takes care of that. Easy 5 marks. All right. Now this part of the question says, show that dou 2w of dou y dou x minus dou 2w of dou y squared is equal to 0. So I'm just going to rewrite back what w was around here. Remember, it said that w was ln 2x plus y minus ln x minus 1. Just to write it down so it's easy to differentiate back again. All right. And we already found out what was dou w by dou x is 2 over 2x plus y minus 1 over x minus 1. So we can write that back. We had already found that dou w by dou x, we found that that was 2 over, this was equal to 2 over 2x plus y minus 1 over x minus 1. All right, so let's go ahead now and find out what is dou 2w. So dou 2w of dou y dou x, it just means that we're going to differentiate dou w by dou x with respect to y. Differentiating this with respect to y, we're going to get, let me see, differentiating this with respect to y, we can start with the bottom times the differential of the top. Using quotient rule, we start with the bottom 0 times the differential of the top 2 minus the top minus 2 times the differential of the bottom. Differential of the bottom is 1 over the bottom square. So we use quotient rule to differentiate it over 2x plus y all square. And this part don't have no y in it, so it's just a constant. So differentiating with respect to y, we get minus 0. And so dou 2w of dou y dou x is equal to minus 2. This works out to be minus 2 over 2x plus y all square over 2x plus y all square. Nice and easy. Soft. Now we need to find out what is dou W by dou Y. Dou 2W of dou Y squared. We need to find this out. So first remember this was W. So let's find out now. Let's do it in a different color. We're going to find out what is dou W by dou Y. So dou W by dou Y means we're going to differentiate W with respect to Y. So differentiating W with respect to Y, let's see what we're going to get. We're going to be getting, differentiating this with respect to Y, we're going to get 1 over 2x plus y. And then differentiate this part with respect to y, we get minus 0. And so to differentiate this with respect to y again, we're going to get dou 2w of dou y squared. Dou 2w of dou y squared. We're going to get that this is equal to, start with the bottom, using quotient rule again. We don't even need to use quotient rule. Think of this as 2x plus y to the minus 1. So it would just become minus 1, carry down the power, subtract 1 from the power. So it's going to be 2x plus y all squared. So we get dou 2w of dou y squared. And looking at the question, what we wanted to prove is this. So let's see if it's going to be that. So now, as you can see, dou 2w of dou y, dou x minus dou y, dou x minus 2 times dou 2w of dou y squared. That's going to be equal to this again is dou 2w of dou y, dou x. That's minus 2 over 2x plus y all squared. Then minus 2. Now minus 2 times this, that becomes plus 2. So here man, it is indeed 0. So get 2 over 2x plus y all squared. Which is equal to 0. That takes care of this question. Nice and easy, soft. All right, part C. Part C says, find the complex number u such that u, which is equal to x plus iy, is such that x and y are real numbers and u squared is minus 15 plus 8i. So this is what they said. They said u is equal to x plus iy. U is equal to x plus yi. And so if I were to square both sides, I would get that u squared is equal to x plus yi all squared. X plus yi all squared is x squared minus y squared plus 2xyi. All I did was square this to 2xyi. That would be u squared. But look at this, u squared is also equal to minus 50 plus 8i. All right, u squared is also equal to minus 15 plus 8i. Now, since these two complex numbers are equal, then this must equal this. So their real parts must be equal, and their imaginary parts must be equal. So that implies that we're going to get that x squared minus y squared is equal to negative 15. X squared minus y squared is equal to negative 15. And we're going to get that 2xy equating their imaginary parts. 2xy must be equal to 8. 2xy must be equal to 8. So if 2xy is equal to 8, then what we can do is make y the subject. To make y the subject, we divide both sides by 2x, and we're going to get y is equal to 4 over x. If y is equal to 4 over x, we're going to substitute that into equation 1. Substituting y as 4 over x, then what we're going to get is x squared minus y squared is now going to become 4 squared is 16 over x squared. 4 squared over 15 is equal to x squared. And if I bring over the 15, it becomes plus 15. And that is equal to 0. Now, this equation is going to be complex to solve. So I'm going to multiply through by x squared. So we're going to multiply this equation through by x squared. And by multiplying through by x squared, what we're going to get is x to the 4. Instead of putting the minus 16 here, I'm going to put plus 15x squared plus 15x squared minus 16, and this is then going to be equal to 0. All right, nice and easy. So that's going to be equal to 0. So what can we do now? What we can do now is factorize. This is just a hidden quadratic in x squared. So we're going to factorize it, and of course it's equal to 0. So it's going to be x squared. Now, which two numbers when we times them we get minus 16 and add them and we get 15? That's 16 and 1. That is 16 and 1. Signs are different and the bigger number is positive. So the plus goes here and the minus goes here. And so that means that is x squared is equal to negative 16. But this one is not valid. This one is not valid. And this one is not valid because x squared can't be negative 16 because x is a real number. So this one is not valid. And so all we're left with is x squared is equal to 1. And if x squared is equal to 1, we're getting that x is equal to plus or minus 1. So x is equal to plus or minus 1. Now, if x is equal to plus or minus 1, then what we're going to get for y is equal to, substitute 1 here, and say you get plus or minus 4. All right, y is equal to plus or minus 4. That gives you x and that gives you y. So what does that imply? That implies that you plug it up here and say u is actually going to be, so find the complex numbers. I'll write the answer up here. So u is actually working out to be 1 plus 4i. That's one possible answer. U is equal to 1 plus 4i, or u is equal to minus 1 minus 4i. Those are the two possible values of u. Nice and easy. So here they are. Those are the two answers. Okay, that takes care of part C. Too easy, soft. We go to this now. It says hence or otherwise solve this quadratic equation. Once they say hence, just know that somewhere along the way we're going to use the fact that the square root of 15 plus 8i is equal to plus or minus 1 plus 4i. We're going to use that some way along the way. So let's do that. So to solve this quadratic equation in Z, we're going to use a quadratic formula where Z is equal to minus B. So Z is going to be equal to minus B is 3 plus or my, well, my apologies. The coefficient of Z is 3 plus 2i. I don't know where plus or minus 1 come from. So it's 3 plus 2i. That is Z plus or minus the square root of B square minus 4ac. B square is going to be 3 plus 2i square. 3 plus 2i square minus 4 times 1 times 5 plus I. So minus 4 times 1. I won't need to put 1 there. I'll just put 4 times 5 plus I. And that's and this is all being divided by 2 times a. The coefficient of z squared is 1, so it's just being divided by 2. So let's finally work it out. So z is going to be equal to 3 plus 2i. Z is equal to 3 plus 2i plus or minus the square root of 3 plus 2i all squared. The first term square is 9. That's 9 plus twice the product of the two. 2i times 3 is 6i. Twice that product is going to be 12i plus the second term square. But then 2i all square is 4i squared, but 4i squared is just minus 4i. It's just minus 4 rather. 2i squared. 2i squared is just minus 4. All right, and then minus 4 times 5 is minus 20. And then 5 minus 4 times 1 is just minus 4i. And remember, everything is being divided by 2. So what do we get? We're getting then that z is working out to be, get it? Z is working out to be, that sounds nice. It has a nice ring to it. So we're getting z is equal to 3 plus 2i plus or minus. Now 9 minus 4 is 9 minus 4 minus 20. That's minus 15. So we end up getting the square root of minus 15 plus 8i. Minus 50 plus 8i over 2. But remember it said hence and it said hence. It said hence. So go right ahead. Remember the square root of minus 15 plus 8i is u. The square root of this is going to be 1 plus 4i. Yeah, man. And so what we're getting then is, because we know it is 1 plus 4i, we can write, and so z is going to be equal to 3 plus 2i. Going with the plus first, plus 1 plus 4i over 2. That's one possibility. This is one workout for z. Or the next possibility is z is equal to, when it have the minus now, so it would be 3 plus 2i minus 1 plus 4i over 2. All right, so those are all these don't look like a plus so much. So these are the two possible values for z. So we're getting then that z is equal to 3 plus 1 is 4, 4 over 2 is 2. We get 2 plus 2i plus 4i is 6i, 6i over 2 is 3i. So z is equal to 2 plus 3i, comma, or z is equal to 3 minus 1 is 2, 2 over 2 is 1, and then 2i minus 4i is minus 2i, and minus 2i over 2 is minus I, and so that is z. Z is equal to 2 plus 3i, or z is equal to 1 minus I. Those are the answers. So that completes question number 1. Nice and easy, soft. Moving right along. Question 2. Question 2 says, use integration by parts to derive the reduction formula. It says use integration by parts. All right, so first we have to start with is in, since we're using by parts. We're going to start with in, and in is equal to, so we have to remember what is Euler's rule. For Euler's rule, what are we going to substitute for u and what are we using for dv? You have to remember Euler's rule that tells us that the integral of u dv is equal to uv minus the integral of v du. That's Euler's rule, or integration by parts rather. And Euler's just tell us that algebra comes before exponential. So that means we're going to use u as x to the n. U is x to the n. And so du is going to be differential of x to the n, which is n times x to the n minus 1. And so dv is going to be e to the ax, e to the ax. And so v is going to be the integral of e to the ax, which is e to the ax over a. E to the ax over a. So using reduction formula, in is uv, u times v is going to be x to the n times e to the ax over a. When I work that out, that will be x, that will be x to the n, e to the ax over a, minus the integral of v du. The integral of v du is going to be minus the integral of v times du. V times du will be n. I'm going to factor out 1 over a. Factor out 1 over a. And I'm left with n times x to the n minus 1 times e to the ax dx. Now, I think I will factor out n as well. I will factor out n. Instead of writing as 1 over a, I'm going to write it as n over a. Factor out n as well. And so now if I multiply this by a, notice that what is this? If I multiply this by a, if I multiply this side by a, and then this is then multiplied by a, and also this is multiplied by a, then the a will cancel the a here, and the a cancels the a here. And so then what I get is that a times in, so a times in is equal to, this becomes x to the n, e to the ax, minus, now this becomes n times, now x to the n minus 1, e to the ax is just in minus 1. Replace n with n minus 1 from the original formula. And so we've shown it. Nice and easy, soft. So it is proven. Proven. Nice. So let's go to part 2. Part 2 says hence determine the value of the integral of x cubed e to the 3x. It's a hence, meaning we're going to use this. All right. So I noticed that if I let n be equal to 3 and a equal 3, then I'm going to get this. Can I use this formula? Let n be 3, so I3. So we're really going to find this right here is I3. So we're trying to find I3. All right. So I like to write it down what we do. We're going to let a be equal to 3 and n be equal to 3. So if we let a be 3 and n be 3, we're going to get that this becomes 3 I3 is equal to, because remember this by right is I3. So all we need to do is divide by 3 to get I3. So I3 is going to be equal to x cubed. So it's going to be equal to x cubed e to the 3x minus n times, which is 3 times 3 minus 1 is I2. So now we need to find out what is I2. All right, we need to find out what is I2. So finding out what is I2, we can find out what is 3 times I2. So we keep a as 3, but now n as 2. So 3I3 is going to be equal to x cubed e to the 3x minus now 3I2, meaning we're changing now into 2. Changing into 2 in this formula, it is just going to be x squared e to the 3x minus n is now 2, so it's 2 times. They will change this to 2 minus 1, which is just I. Nice. Minus 2I1. Good. So I'm just going to expand this bracket now to say 3I1 is just x cubed e to the 3x minus x squared e to the 3x and then minus and minus become plus. That becomes plus 2 times I1 plus 2 times I1. All right, that becomes plus 2 times I1. So now we need to find out what is I1. To find out what is I1, we'd have to plug in 1 of, so we're going to have to divide through by a to get what is I1. So I1 means we're going to put n as 1. And so what we're going to get is x cubed e to the 3x minus x squared e to the 3x minus x squared e to the 3x plus 2 times what is I1. I1 is going to be plugging in n as 1, but also we have to remember that we have to divide through by 3. And so remember that a times in is this. And so we had to divide through by a to get what is actually in. And so in reality, our truth be told, what we're going to get for I1 is x to the n. In this case, n is 1, so it's just going to be x times e to the ax. A is still 3. And this is being divided by 3. You say, why is it divided by 3, sir? Again, a times in is this. So I have to divide through by 8 to get what is in. So it's divided by 3 minus n times, in this case, n is 1. So it's minus 1 minus 1 is just I naught. I naught. Nice and easy. Soft. Okay. So all I need to do is find I naught and this question done. This was a really nice question. And remember, this is 3i3. So I don't want anybody to forget that this is 3i3. All right, this is 3i3. So we're going to have to divide through by 3 somewhere along the way. So what we're getting is 3i3 is x cubed e to the 3x minus x squared e to the 3x plus 2x e to the 3x over 3 minus 2i naught. And then you're going to ask the question, so sir, how do you find I naught? Because we can't plug in 0 right here. If we plug in 0 in this formula, you're going to get 0 minus 1. But no worries. What we're going to do is go back to the original formula and plug in as 0. If you plug in as 0, yeah, in the original formula, if you plug in as 0, you get x to the 0. Anything to the 0 is 1. So you just get e to the ax, where ax is 3. When you integrate e to the 3x, you just get e to the 3x over 3. So that's I naught, e to the 3x over 3. So what we're getting then is, I'm going to divide through by 3. No, not yet. I'll divide through by 3 soon. So I'm going to replace I3 with this now. And so what I'm saying is 3 times the integral of x cubed e to the 3x dx is equal to x cubed e to the 3x minus x squared e to the 3x plus 2x e to the 3x over 3 minus 2i naught. And remember, we said that I naught is e to the 3x over 3. And so it's going to be minus 2 times e to the 3x over 3. And remember, when you integrate, you always put plus some constant. Well, not necessarily, because it's, yeah, we don't need to put no plus c. Let's leave it there. We divide through by 3, we can put constant. So dividing through by 3, we're going to get, so the integral of x cubed e to the 3x dx is equal to, 1 over 3 is equal to 1 over 3 x cubed e to the 3x minus, I know that's kind of hard to see, minus x squared e to the 3x over 3 . And then right here now what we have is 2 plus 2 over 9 plus 2 over 9 x e to the 3x and then minus 2 over 9 e to the 3x. And then when you integrate, you always remember that you add a constant, so plus some constant j. That takes care of this question. Nice and easy, soft. All right, let's continue now. So now, this question is asking us, calculate the integral of 0 to 1 of sine inverse 1 over x squared. To do this type of integration, it's best to use substitution. we can call u sine inverse of x. If u is sine inverse of x, then you can find out what is du. Du is going to be equal to 1 over the square root of 1 minus x squared nice and easy, so that's du. Now the lower limit is equal to when you plug in 0, sine inverse of 0, I don't know. Sine inverse of 0 is 0, that's that I didn't know that. And the upper limit is going to change to plug in 1, sine inverse of 1, pi by 2. So using u substitution, I like to call my integrals I. Just call it I. So that integral I will be equal to now. It's going to be equal to the integral from 0 to pi by 2 of sine inverse of x is now u. So that's the integral of u du. That part becomes du. So when you integrate that now, you're getting u squared over 2. And we're integrating from 0 to pi by 2. So all you have to do now is substitute u as pi by 2. So now you're getting pi by 2 all squared divided by 2. So that's what we get. So doing that, it can finally work out to be pi squared 2 squared. So it's going to be pi squared over 8. That's the integral, pi squared over 8. That's the answer. Nice and easy, soft. Moving right along. Question, part C. Part C says use partial fraction to show that this can work out to be this. All right, so using partial fraction, all right, I'm just gonna call this I. I'm gonna call this I. I just like to call it I. So I can be equal to, as you realize, x cubed plus 4x can be broken up as, if you factor out a x, it would be a over x plus, then you're gonna left back with x squared, x, then you're gonna left back with x squared plus 4. So then it's gonna be plus bx plus c over x squared plus 4. This is what we're gonna have. So we're gonna find the LCM between these two. And the LCM is going to be, again, it's going to just be x cubed plus 4x. That's the LCM. All right. And then x into this leaves x squared plus 4. So it's going to be a times x squared plus 4. It's going to be a times x squared plus 4. Then it's going to be plus bx plus c times x. Bx plus c times x. So that's what we have in the numerator. So since that's what we have in the numerator, now all of this will be equal to 2x squared minus x plus 4 over x cubed plus 4x. Nice. So now since the denominators are the same, we can just equate their numerators. So let's equate their numerators. Equating their numerators, we're going to get that ax squared plus 4a, ax squared plus 4a plus bx squared plus cx, and that is going to be equal to 2x squared minus x plus 4. All right, and so you have equating x squared terms, you're going to have a plus b is equal to 2. That's equating the x squared terms. Equating x terms, you're going to have b is equal to, I say b, c rather, c. C is equal to -1. And then you're going to have equating the constant, you're going to have 4a is equal to 4. Now, since 4a is equal to 4, that implies that a equal 1. And since a equal 1, that implies that put 1 up here, b equal 1 as well. B is equal to 1. So what does that mean? That means that, remember, I call all of that I. And so that means that I, which is equal to a over x, it's going to be equal to 1 over x plus bx, which is x minus 1 over x squared plus 4. That is it. But you can just go further now and rewrite this as 1 over x. And you can separate this in the numerator as 2 separate fractions as plus x over x squared plus 4. X over x squared plus 4. And then minus 1 over x squared plus 4. Nice and easy. So that takes care of part. That's this. So here we prove it, we showed it. 5 marks for that. Nice. Moving right along, it says, hence determine the integral of this. Hence means we're going to use the partial fractions that we have. So I'm going to call this integral I. My style, I don't. Just call all of this I. All right, please. Can't bother write out all of this. So we're calling that integral I. And I is now equal to the integral of, instead of writing all of this, we know it is now 1 over x plus x over x squared plus 4 minus 1 over x squared plus 4. Dx. This is what we're integrating now. Now remember that the integral of the sum is the sum of the integral, so you can separate this as the integral of 1 over x dx plus the integral of x over x squared plus 4 dx minus the integral of 1 over x squared plus 4. So this is what we're integrating now. Now the integral of 1 over x, we all know that it's just ln. Since they're writing so much modulus, let us just be consistent. It's ln mod x plus. Now to integrate x over x squared plus 4, the derivative of x squared plus 4, the derivative is 2x, so we can put a 2 in the numerator and a half on the outside. And so what we're getting is this works out with plus a half ln the denominator now, so it's a half ln x squared plus 4 is a half the mod of x ln x squared plus 4, and then we have minus. Now x squared plus 4, if I were to just put a 2 in the numerator, and a half on the outside, the integral of a over x squared plus a squared is tan inverse x over a. So this becomes minus a half tan inverse x over 2. And since it's an indefinite integral, remember to put plus some constant. I'll call that constant plus a. All right, nice and easy. And that's that question solved. Nice. I'll finish 2 questions just like that. 25 marks, done. We go to module 2. Now we go to module 2.